we're going to look at chapter 7.42. Now, I broke this up into two sections because, well, what we did yesterday is we really talked about special parallelograms. We talked about rhombuses, rectangles, and squares. So a rhombus is a four-sided figure, two sets of parallel lines, but all the sides are congruent. So it has all the properties of a parallelogram. The opposite sides are congruent. Well, actually all sides are congruent. And that the opposite angles are congruent. Not going to do square. We're talking about a rectangle. And the key indicating fact for a rectangle is what? That we have four right angles, yes? And because it's a rectangle, it means the opposite sides are congruent, yes? Well, that's actually because it's a what? A parallelogram. Because all parallelograms, opposite sides are congruent. So just because the opposite sides are congruent doesn't mean it's a rectangle. It just means it's a parallelogram. And then we also had square. And a figure is a square if it's both a rhombus and a rectangle. So if all four sides are congruent and it has four right angles, or all four angles are congruent. So really, we can say a square is a regular quadrilateral. As a regular quadrilateral, it is considered regular if all sides are congruent and all the angles are congruent. So the only way that we can have four angles be congruent in a square or a rectangle is if they are all 90 degrees. So, and as we kind of talked about yesterday, a square is a rhombus and a square is a rectangle, but a rhombus is not always a square and a rectangle is not always a square. So that means a lot of the properties we're going to go over today for a rhombus, so if it is true for a rhombus, the properties of a rhombus are true for a square. And the properties of a rectangle would be true for a square as well. Yes? Because a square is a rhombus, a square is a rectangle. So anything we go over today will hold true for the square. So the first one we're going to look at is, we're going to look at a, well, I'm going to draw a line apparently. Let's go. There we go. A rhombus. So there's kind of properties. There's two main ones that we're going to look at. One of them is that a parallelogram is a rhombus if and only if its diagonals are perpendicular. So if they're perpendicular, it means they intersect at 90-degree angles. They intersect at a right angle. So that means when those two diagonals cross inside a rhombus, will form right angles every single time. They will always cross at right angles. And we also have that a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Bisects a pair of opposite angles. So if it bisects it, it means it cuts it in what? Half. It cuts it in half, yes? It's going to cut it in half. But more specifically, so let's just say angle A and angle C that you have on your diagram. What do we know about those angles, or the opposite angles in a parallelogram? They are what? They're congruent, right? So that means if this diagonal bisects it, that they're going to match up. Because if they're congruent, well, if I bisect them in half, it means those four angles that it made are also going to be what? Congruent, yes? Let's see here. So if this here is a trapezoid and I bisect these angles, well, the whole angle, both of these whole angles are congruent. And if I cut the same thing in half, I should get that these here, all four of these are going to be what? Congruent. Because if the angles as a whole were congruent to each other, well, if they're cut in half, those halves should be congruent to each other. Now, it doesn't directly say that, but when these are cut in half, those corresponding angles are going to be congruent as well. So let's look at that. And that's what we're going to really look at here first, is actually dealing with this here and dealing with these angles and finding these parts. There's going to be an assignment over this. It is in big ideas. Now, what we want to do is we want to find the measured angles that it's asking for, the numbered angles for this here. Now, one of them, actually one, is the easiest angle to find. Because the diagonals in a rhombus do what? They bisect, or they intersect at what? 90 degrees. They're perpendicular to each other. So since this is a rhombus and the diagonals intersect, they're going to intersect at 90 degrees. So what's the measure of angle 1? Do this all day. Anybody know what the measure of angle 1 is going to be? So what do the diagonals intersect at? The diagonals are what? Starts with a P. Perpendicular. Perpendicular lines intersect at what? 90 degrees. They intersect at right angles, yes? So these two lines through the center of this, because it is a rhombus, are perpendicular, yes? So they intersect at what? 90 degrees. So what's the measure of angle 1? 90. What are any of those angles right there with angle 1? They're all 90. So anytime we see a rhombus, especially this here, well, that's kind of nice, isn't it? But just because it's a rhombus, when those two intersect, those two diagonals intersect, that point of intersection will always be 4 90-degree angles. It's going to work out that way. It's kind of nice, isn't it? Okay, so we have that one there. Now so now we need to find the other angles, yes? Because we know 1 is 90. But now we kind of need to know the rest. Well, I know one of the angles at C is 61 degrees. Yes? What was the other postulate or kind of theorem we just kind of saw with rhombuses? Because we have the diagonals, one are perpendicular to each other. What was the other one? The opposite angles theorem. So it says if a rhombus is a parallelogram, then what? A parallelogram is a rhombus if and only if each diagonal what? Bisect a pair of opposite angles, yes? So bisect means cut in half. Well, if this is 61 degrees, what's the other one right next to it? So this angle here has to be 61 degrees, yes? Because that diagonal bisected in half. Because that's just what that theorem states. Well, using that same thing, well, that means the measure of angle 2 and the measure of angle 3 are going to be what? Yeah, they'll be equal to 61 degrees. They're going to be equal, yes, because that diagonal cut it in half. Just like the 61 and 61, it cut it in half. They're the same. So those are going to be the same. Now, could we say that angle 2 and 3 are 61 degrees? Because is a rhombus a parallelogram? Well, yeah, all of these are parallelograms, yes? And the opposite angles in a parallelogram are congruent, yes? So that meant that both of these 61 degrees, this whole angle would be congruent to both 2 and 3, yes? We could, yes, we could actually say that. We could go about it that way using opposite interior angles with parallel lines. So it'd work out that what? These are both 61 degrees, because if the whole angles are congruent and we cut them in half, yes, if I cut one in half and I cut the other in half, they'll be the exact same, yes? Okay, so what does that leave us with? The measure of angle 4, yes? Well, it'd been really nice if we had some angles over at angle B, wouldn't it? If I had an angle measure over here, because they would flip over. So let's see what we do know. So I do know angle 1. I know that all the red angles, except for angle 4. Are there any other shapes in there that we could use? A triangle, yes, because any three angles in a triangle add up to be 180. So if we could use that, well, hey, isn't that a triangle right there? Do I know angles 1 and 3? So I can use the fact that angle 1, which is 90, plus angle 3, which is 61, plus x is equal to 180, because those three angles inside that triangle add together to be 180. Well, 61 plus 90 would be 151. And we could subtract it from both sides. And this here would give us 29 degrees. Now, if you really wanted to, I mean, we could have just added those two angles together and subtracted it from 180. That would have worked just fine. But that's it. Any questions on this here? Any questions on any of this here so far? Just when you thought you were getting away from triangles, they show back up. So let's look at this one here. Now this one here is not any different than what we just did. It's just different numbers. So we have 1, 2, 3, 4, and I'll just go on and list these out. Measure of angle 1, measure of angle 2, measure of angle 3, of angle 4. So looking at these here, is there one in particular that we can find a little bit easier than the rest? Well, 1, because what is 1? 90. That's kind of nice. They intersect at right angles, yes? What's another one we could find? 2 and 3, what are they going to be? 61. Because the opposite angles inside of a parallelogram are congruent, and the angles, what am I trying to say? And the diagonals bisect each other. So those 4 angles are going to be congruent. That leaves us with angle 4 again. So how can I find angle 4? The triangle. This triangle here. Okay? And that adds up to be 180. So we'd have x plus 61 plus 90. And this would here would be 151. And if I subtract 151 from both sides, exactly, we'll have x is equal to 29. Questions on this here? Well, I feel like, yes. It is. It is the exact same question. I put that on there twice. Okay. Ah. I didn't read the directions. What does the directions actually say? The measure of ACB and ABC. And finding that's not any, and it is good because we did get these back. the fact that this is 29, 61, 61, and 90. Now, what is ABC? ABC is this whole angle here. Well, we found angle 4 is 29, yes? So the other angle down here is going to be 29, yes, because it cut it in half. Well, this whole angle here is the same as this whole angle here, this ABC, yes? So what would I do to find it? Because these two here are the same as these two here, yes? So what would these two here be? They're 29 and 29, yes? Yeah. Yeah. What did you say? Right? 29 and 29 would give us what? 58. So this whole angle here, this whole angle right here would be 58, yes? And the opposite angles are, so ABC would be 58 degrees. ACB is, well, 61. We kind of already found that because, again, the angles are bisected. They're cut in half. Questions on this here?
How did you get
So A, B. So it's just those two angles together. Each one of them would have been 29. And if we combine them, we get 58. All right, we're going to skip that one because that's exactly the yes, sir. Yes. So that's the exact same thing. It's just asking for different angle measures. Now this one here is a little bit different, yes? Because we have one diagonal instead of what? Two. So it doesn't give us the nice one where one of the angles is going to be 90 degrees, where the two diagonals intersect, yes? But what do I know about angles 1, 2, 3, and 4? Well, they're both triangles. I have two triangles, yes. Because that's going to be helpful. We're going to need that. They're congruent because the opposite angles are congruent, yes? So 1 and 2 and 3 and 4 together would be congruent to each other because the whole angle, I'll draw that in, but these angles as a whole and these angles as a whole would be congruent to each other. Would we agree with that? And we know that the diagonal what? Bisects those in half. So angles 1 and 2 would be congruent, and 3 and 4 would be congruent. So 1, 2, 3, and 4 would all be congruent to each other, yes? And yes, we do have two triangles, don't we? So this triangle here, 1, 3, and 118, these here would add up to be what? 180, yes? So we could set that up, and I can say 180 equals what? 118 plus what? X and X, or 2X. Because I know angles 1 and angle 3 are congruent to each other, yes? So the value of 1 would be the same as the value of 3. So we can just both call them X. So X plus X would give us 2X plus 118. Now we just need to solve for the value of X. And once I get the value of X, I will actually know angles 1, 2, 3, and 4. Well, the first thing we need to do is what? We need to subtract 118. When we subtract 118 from both sides, well, 118 minus 118, these will cancel. Gives me 2X. And 180 minus 118 will be 62. And last but not least, divide both sides by 2. And we get x is equal to 31 degrees. So the measure of angle 1, the measure of angle 2, the measure of angle 3, and the measure of angle 4 are all 31 degrees. Let me show you the real shorthand version of this. Because they'll do it. Because we said what? The measure of angle 1 is equal to what? The measure of angle, which is equal to the measure of angle 3. This the answer, a little more room. As we said, that's true, right? And this here is equal to the measure of angle, which is equal to 31 degrees, right? Because 1 is equal to 2 is equal to 3 is equal to 4, which is 31 degrees. And textbooks will do this, especially on the answer key. If they know multiple angles are the same, they'll say 1 is equal to 2 is equal to 3, all the way out is equal to this measure, instead of relisting it out multiple times. But that statement's true, isn't it? Hmm? Questions on this here? You ready for what's next? The rectangle diagonal theorem. And actually, y'all already know what's in the space. A parallelogram is a rectangle if and only if the diagonals bisect each other. If and only if, if the diagonals are congruent. I got ahead of myself. If and only if the diagonals are congruent. This is a rectangle if and only if AC is congruent to BD. It's only true if AC is congruent to BD. I think that's listed. And it actually does work out that these diagonals will bisect each other, I believe. I'm trying to remember if that theorem's in here. But these diagonals are congruent to each other. And what we could do is if we wanted to delve into this, we could use our triangle congruency statement, side, 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 angle, side, to show that this is true. But the diagonals are going to be congruent. Now, if you're building a window, they have a nice window drawn for us. The window will be installed in the opening shown. So, actually, they didn't draw the window. They showed us where it's going to go. The opening must be a rectangle. Given the measurements in the diagram, can you assume that this is a rectangle? Well, the opposite sides are congruent, right? So it must be a rectangle. What was our definition of a rectangle? It had 4 what? Do we have 4 right angles? Do we know anything about the angles? It is a parallelogram. So what else? Because we just had another one that said if the diagonals are congruent, then it is a rectangle. So we know what the diagonals are, right? Well, no, right? Well, we haven't covered it in here yet, but the Pythagorean theorem would work, wouldn't it? Because I can find the hypotenuse of a triangle. Because the diagonal going from here to here would be the hypotenuse, and I can use the other 2 sides to find the diagonal, yes? But we'll get into this, is the fact that if it is a right triangle, then a squared plus b squared equals c squared. Do I know that's a right triangle? Do I have a right angle? Well, no, we already said we don't know the angles, because if we knew they were right angles, then we knew it'd be a rectangle, yes? So no. No, we don't know the angle measures. Because if we knew what the angle measures were, then we could determine if it was a rectangle or not. And the only way we can use the Pythagorean theorem is if we know that those are right angles in the corners. But if I knew the angles in the corners were right angles, would I need to use the Pythagorean theorem? No, then we'd already know it's a rectangle. Questions on this here? Okay. For those of you who noticed a little bit farther down on the page, they gave us some different information this time, yes? You measure the diagonals of the opening. The diagonals are 54.8 inches and 55.3 inches. Can you conclude the shape of the opening now? Can you conclude now? No, because what? The diagonals have to be what? Congruent, because for it to be a rectangle, the diagonals have to be the same. So the diagonals aren't the same, so that means this cannot be a rectangle. Yep. Here's the diagram in example 4. Okay, we got it. Suppose you measure one of the angles of the window opening, and it measures 90 degrees. Can you conclude that this opening is now a rectangle? So how many do we need total? 4. So we know the opposite sides are congruent. Yes, they're still congruent. So we looked at this on the first question. We said we could say it was a parallelogram, yes? What do we know about parallelograms? Because the opposite sides are congruent. That's why we could say it's a parallelogram. But we also know the opposite water congruent. The opposite angles are congruent, yes? So if this one angle is 90 degrees, it means the angle opposite it would be 90 degrees. Because we also know that the consecutive angles, the angles next to each other, are supplementary. They add up to be 180, yes? Well, if one of them is 90, the other has to be 90. That's the only way we can have 90 plus 90 is 180. So in a four-sided figure, if I have in a parallelogram, I'm going to say that because that's going to be the more math accurate statement. In a parallelogram, if I have one right angle, what are the others going to be? Right angles. So in any rectangle or any kind of parallelogram, how many right angles do I need to actually draw? 1. Because if I have 1, the others must be And that's the nice thing with mathematics, or with geometry, because if you started noticing a lot of the stuff we're doing, we've needed what? Less and less information. Because when we started the year, we would need almost everything, yes? Because at the start of the year, for me to figure out that this is a rectangle, well, I would have needed to know something about every single angle and every single side. Well, now we just need to know it was a parallelogram and one angle, and we found 3. That's what's nice with this here, these geometry proofs. What we're doing is that I'm needing less information to solve for more things. Find the diagonal's length in a rectangle. QRST. If QS is 5x minus 31 and RT is 2x plus 11, find the length of the diagonals of QRST. What do I know about the diagonals? They're what? That would be rhombus, because the rhombus is diagonals intersect at right angles. Yes. So a parallelogram is a rectangle if and only if its diagonals are congruent. So what do we know about these two diagonals? They're going to be congruent. So that means what? QS is equal to RT. That's just by definition, yes? Well, if I want to solve for the lengths, well, they told me what QS is. So I can replace that. Is equal to, well, RT is 2x plus 11. That's because we know that's what those are equal to. Those QS and RT are congruent to those. So we can replace those. We can substitute those in. Now we need to do what? Solve for the value of x. But are we trying to find the length? Well, if I want to know the length, I need to know the value of x. And once we find that, we plug it back in. Yeah, we can minus 2x. That'll work. We can minus 2x from both sides. And 2x minus 2x will. So 5x minus 2x will give us 3x. Exactly. We need to add 31 to both sides. Because again, we're still trying to get x by itself. We add 31 to both sides. Well, negative 31 plus 31 will cancel, giving us 3x is equal to 42. And last but not least, divide both sides by 3. And we divide both sides by 3, we get what? X is equal to 14. So that's our answer, yes? X equals 14. We have to plug it back in. Because again, the direction said to find the length of the diagonal. So I'm going to erase this here because we found x is equal to 14. Do I need to plug it into 5x minus 31 or 2x plus 11? Either, because they are congruent. So I can do 5 times 14 minus 31. Well, 5 times 14 would give me 70. And 70 minus 31 would be 39. So the length of both diagonals would be 39. That's it. Questions on this here? Questions on any of this here so far? I know we have 2 left. Let's just do one more, and then we'll call it good, because I have a feeling if we get this one, y'all are definitely going to be able to get the next one, yes? So looking at this here, we want to find the lengths of the diagonals. Well, we know the diagonals are congruent, yes? So it means AC is going to equal BD. Those two diagonals are going to be congruent. Or more specifically, we can say what? That 7x minus 15, bless you, is equal to 2x plus 25. So what can we do first? Add. I've heard add and subtract. Yeah, it's minus 2x. I mean, we could add, because I have a feeling someone was going to say add 15. Yes. That's fine. I mean, there's nothing wrong with that. Okay. Now we'll have to add 15 to both sides. Because negative 15 plus 15 will cancel, telling me that 5x is equal to 40. And last but not least, we would divide both sides by 5. And we would get that x is equal to 8, yes? And if we plug it back in, 5 times 8 minus 15. 7x, thank you. I was just hoping it was nicely put right there, but no, 7x. So 7 times 8 minus 15. I was about to get the wrong answer. 7 times 8 is 56, and 56 minus 15 is 41. We agree with 41? All right. That is all we are doing today. That's all we're doing with this here. We have 2 last shapes that we're going to look at with these here, with these quadrilaterals. And that is going to be kites and trapezoids. Kites and trapezoids are the last 2 shapes we are looking at. And then we're done with chapter 7.